Hello students, today we are going to look at exponential functions. Now before we get deep into exponential functions, I want to do a quick review. Okay, we've done two other types of functions already this year. We did linear functions, and if you remember linear functions, the parent function was y equals x. You might have seen it as y equals mx plus b or something like that, but the parent function for linear is y equals x. And we looked at quadratic functions as well, and in quadratic functions they formed a parabola, and so the parent function for quadratic functions was y equals x squared. Linear just has an x, quadratic has an x squared. So today we're going to introduce something to you that is called an exponential function. Okay, and so we're going to talk about exponential functions. We're going to see how to identify an exponential function from a table, and then we're actually going to graph some and identify some key features of the exponential function. Okay, so an exponential function is written in the form of y equals a times b to the x power. So in this case, x is now an exponent, where a is the y-intercept, b is the common factor, and x is the exponent. Now when you graph an exponential function, you form a smooth curve. And we'll show you all these things in just a few minutes, but I want you to have the notes written down so you can always refer back to it. Now, a new word that you're going to learn this year is the word asymptote. Okay? The asymptote of an exponential function is the line the graph approaches but never touches. And it is always written in the form of an equation. Just like the axis of symmetry is always written in the form of an equation, the asymptote is always written in the form of an equation. Okay? So let's, before we get into the pictures and drawing and graphing and all that, let's just talk about what an exponential function looks like from a table. Okay? Now we said that b is the common factor. That means that the y values have to be multiplied by something, the same thing, to get to the next y value. You'll remember in linear equations or linear functions, we added something to the y values to get to the next y value. But within exponential functions, we have to multiply. So let's see, we've got, it says determine whether a set of data shows or displays exponential behavior, write yes or no, explain why or why not. So let's do what happens. From 9 to 12, we add 3. From 12 to 15, we add 3. From 15 to 18, we add 3. Because we're adding 3, the answer is no, because it's linear. Anytime we're adding in the y values, that's linear. Now we could also go do plus 1, plus 1, plus 1 up there. Okay? Let's look at number 5. Number 5, how do I get from 20 to 10? Well, you could say subtract 10. Well, let's say from 10 to 5. Well, that's not subtracting 10. So when I see that there's not a common difference, let's see if there is a common factor. 20 times what equals 10? You're right, 20 times 1/2. Okay? I shouldn't put the x. I need to put a dot. That's dot for 1/2. 10 times what is 5? It's times 1/2. And then 5 times what is 2.5, and that's 1/2. Now if you don't know, if you can't figure it out, then just take your calculator and do 10 divided by 20 and you get 1/2. Or 5 divided by 10, you get 1/2. 2.5 divided by 5, you get 1/2. In the x values, we're adding 5 to each one. Now in the x values, you need to be adding the same number. In the y values, you would be multiplying by the common factor. So for an exponential function, I'm multiplying by a common factor in the y and adding by the common difference in the x's. So this is an exponential function because the common factor is 1/2. Okay? Now, I want you to do 7 and 8 on your own once the video is finished so that you can tell me if 7 and 8 are exponential functions. Okay? So now I'm going to fold the page so that you can just see what's going on here, and we're going to get more involved with this, and we're going to be using our calculator. So you will need a calculator because that's going to help us find our table. Okay? So now it says graph each exponential function, identify the y-intercept, domain, range, and asymptote. Okay? So first of all, let's look at it. We have y equals a times b to the x. 4 is a, 2 is b, x is the exponent. Now, we're just going to plug that into the calculator and see if we can come up with the table of values so we know what points we can plot. So we're going to turn the calculator on, and we're going to go to a new document, and we're going to go to a graph, and we're going to type in the function just like we see it with parentheses and everything. 4 parentheses 2 raised to the power of, which is the key right next to the x squared, to the power of x, close parentheses, enter. And there we have our smooth curve, which is exactly what you wanted. But we also need our table of values. So we're going to go to Control T, and we're going to see the points that we want to plot. Notice I'm going to use the up arrow, because typically when we plotted a graph we started with -2, -1, 0, 1, and 2. So we're going to do the same thing. So I'm going to plot -2, -1, -1, -2, 0, 4, and 1, 8, and the next point would be 2, 16, which we can't get to. So let's go ahead and go up one more, and we'll do -3, 0.5. -3, 0.5. So now when I draw this, I'm going to draw this smooth curve. I missed a point here. And let's go back to the graph, and you see I have my smooth curve, and it keeps going with an arrow on both ends. So let's talk about the y-intercept. Where did this cross the y-axis? At 4. Because it's A right here, and we can tell from the graph that it crossed the y-axis at 4. The next thing we need to identify is the domain. Just like almost everything else in algebra, the domain is all real numbers. This year with domains, it's going to be all real numbers, and we're going to write that -infinity is less than 0 is less than infinity. Okay? Now the range. Here's where the range comes in handy, or it comes in, and the graph comes in handy here. If you look at this graph, I'm going to do Control T to get rid of the table. You can see that this graph, the smooth curve, really gets really close to the x-axis, but it never actually touches it. And if you went back to the table, you could look at the table, and you could scroll all the way up, and you would see that you would never get to the number 0, ever. So the range is going to be y is greater than 0. All of the y's are above the 0 line. You might also see that written as 0 is less than y, which is less than infinity. You could see it written in both ways. Okay? Now, let's talk about the asymptote. Now, if you remember from the top of the page, the asymptote is the line that it approaches, but it actually never touches. And in this case, that is the x-axis, and the equation of the x-axis is y equals 0. So I'm going to draw it in a different color. The smooth curve will never touch this line, y equals 0, which is our asymptote. Okay? So we got the y-intercept, the domain, the range, and the asymptote. We've identified everything that we need to with our smooth curve. So let's look at number 2 together. And I just noticed that 6, 7, 8, and 5, 6, 7, and 8 are at the top. 1, 2, 3, 4 at the bottom. Oh well. On number 2, we're going to do this one together as well. I'm going to move the calculator over a little bit so that we can see it. And show you a trick. In order to get to a new page, blank page, you can just hit a new page. Go to Control Dock, and it takes you to a new page, and that makes it easier than having to clear the memory and everything. So we're going to add a graph. And we're going to graph 1/3 to the x power, so parentheses 1 divided by 3, close parentheses, raised to the x. And we're going to hit enter, and there is our graph. Ooh, looks different, eh? So now what we've got to figure out is all of the information that we need. So let's go back to our table, Control T, and let's look at some points. We're going to start with -2. And we're going to go 9. -1, 2, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to go -1, 3. And we're going to go 0, 1. And then we're going to go 1, 0.3 repeated. Remember, 0.3 repeated is 1/3, so we're going to go 1, 1/3. And then we're going to go 2, 1.1 repeated would be 1/9. So it's going to go down here. And then if we just did one more, that's going to be 1/27th, so it's going to get closer. And now we can draw our smooth curve. Trying to get all of those points in. I missed a little bit. Put an arrow, put an arrow. Okay, now let's identify all our key features. What's the y-intercept? Exactly, it's 1. Because there's no number in front of the number that has an exponent of x, so we know that's 1. Y-intercept is 1, and then the domain, you're right, it's all real numbers. -infinity is less than 0, is less than infinity. And the range, looking at the graph, or you can look at the one you drew, what is the lowest number, or the number where all of the y values are above it, and that would be y is greater than 0. Again, it can be greater than or equal to 0 because it never touches the 0 line. And the last thing is our asymptote. And we're lucky because the asymptote is the same here. The asymptote is y equals 0 because it never touches the x-axis. And the equation for the x-axis is y equals 0. And you can look on your graph and see you can keep going and you'll never get to a 0. Okay? So identifying the key features, the y-intercept, the domain, the range, and the asymptote. Now I'd like for you to do these other two on your own and then have them ready when you come to math workshop.